Hi, it's Greg Harrell here, and tonight or today even, I want to talk about getting a Linux keyboard to behave like a macOS keyboard. And the setup here is a little different than usual because I've been setting up a Linux machine and it's not fully set up yet. So for example, it doesn't have a webcam, it doesn't have a microphone. So I'm standing in front of the Linux machine. I'm going to capture the screen there so you can see what I'm doing. But it's actually my Mac laptop over here that's responsible for recording my voice and also the camera, obviously, of me. And I've got my phone here filming the keyboard because although I have screen keys on, you'll be able to see what the OS thinks I'm typing. You really need to see the camera of my fingers on the keys to see what I'm actually hitting. One thing to note about this keyboard is the keys are all kind of those ninja keycaps. Well, not all of them. All the letter keys are faceless, so they don't have anything written on them. And these other keys, like the number keys and these ones around here, they do have stuff written on them, but it's very kind of stealthy, so you can't really see it unless you look at it very closely. Which, by the way, if you ever want to get better at typing and force yourself to touch type, I strongly encourage picking a keyboard with blank keycaps because it's great. There's literally no temptation to look at the keyboard if you've got keycaps like that. Okay, so let's start by talking about why I'm even doing this. And there's a lot to say, and so this screencast, I'm probably going to race through it pretty quick. And even though I'm racing, I'll still probably be talking for quite a while. So consider this an overview and intro, and later on I'll break it down into smaller, more detailed screencasts about specific topics. But for now, I just want to set the context and show where I am with this whole Mac-style bindings on Linux thing. So why am I doing this? Well, I've been frustrated with Apple for a while now, and so I've consigned myself to having to live with two different operating systems. My plan is to use Mac for what it's good for, and use Linux for what it's good for. I have always preferred the simplicity of just having one machine, but Apple laptops haven't been that great, at least the one I've got. I haven't got a fancy new laptop with an M1 chip. And so, thermal throttles, it's slow, the fan is super noisy, and I've just been super frustrated with it for development work. So I want to do most of my development work on Linux, where, obviously because most of that is in the browser and in the terminal, it'll be exactly like my workflow was on Mac, but just faster. And then keep using Mac for the things that Mac's good for. So there's a number of apps on Mac that I just really like, and I can't really see myself finding replacements for them on Linux yet. So that's why I'm doing it. And then when it comes to the fact that I'm going to have to live with two operating systems for the foreseeable future and be jumping back and forth between them, I obviously don't want to have to learn two completely different systems. So I have to choose. Do I want to make the Mac behave more like Linux, or do I want to make Linux behave more like the Mac? And I'm going with making Linux behave more like the Mac, probably for three reasons. One is it's probably more hackable than the Mac. I obviously have more control over Linux than I have over what Apple does with its operating system. Another is that I am obviously more used to the Mac because even though I've worked on Linux machines for well over a decade now, that's always been over SSH. And so in the terminal, I'm already highly familiar with the environment, but at the desktop layer, all of the desktop layer shortcuts are totally dominated by my macOS muscle memory because I've been using Macs for 25 years now. And then finally, the third reason why I'm choosing to bring the Mac style over to the Linux is because I actually think the Mac style is better. And I'll go into that in a few minutes about why I think it's better. So there are two levels that we have to deal with here. And one of them is just making the base level kind of built-in behavior act like a Mac keyboard. And the other is a more kind of sophisticated hacky layer where I've got some arcane stuff, custom stuff in Mac that I want to bring over to Linux. So this is my .files repo that we're looking at right now. If we find keyboard customization, you'll see here a list of things that I'm doing on macOS to enhance the keyboard. So the first one here is make caps lock into a dual purpose key. So when I tap it, it acts like backspace, which is what caps lock does in the Mac keyboard layout. But when I hold it down and chord it with another key, I'm going to get a control modifier. I do the same thing with return on the right side over here for symmetry, because ideally when you want to actuate a modifier key, you want to hold the modifier with one hand and the other key with the opposite hand, so that you minimize like painful stretches. So, for example, a very common one here is Control W to delete a word in the terminal. So for me, that's like right pinky on the return key and left ring finger on the W key. Then there's this one here, map Control-I to F6, but only in MacVim. So the reason for that is that when you're in the terminal, Control-I and Tab are actually the same character. So Vim can't tell the difference between them. But I want to use those two key presses for different things in Vim. So the way I do that is by turning one of them into a different key press. So Vim, instead of seeing the same key, it sees F6 or Control-I. And so in that way, I can use Control-I for its default purpose, which is to move into the jump list in Vim. And I can use Tab to toggle folds open and close. So I've got two mappings, both in normal mode, that Vim would see like being indistinguishable, but thanks to this hack, it sees them as two separate keys. Then we've got this, for example, because caps lock has been turned into a completely different key, we need another way of turning caps lock on. So for me, that's tapping both shift keys at the same time. So that's done with carabiner elements. And this, as I said, is more of a kind of esoteric, hacky layer that you can't do out of the box with macOS. But then there's all the stuff that you can do out of the box. And so let's have a look at what the Mac keyboard actually looks like. So the command key here, which is called Alt on Windows and Linux, that's used pervasively in macOS to do what I would call universal shortcuts that work pretty much across the entire operating system and basically all applications. So if we just read some of them off, Q to quit an app, W to close a window, A to select all, S to save, Z to undo, X to cut, C to copy, V to paste, did I say F to find, G to find again, and then in applications that are tabbed, which nowadays is quite a few, T to create a new tab. In an application like Chrome, R to reload. So a lot of those are on the left hand, interestingly. But you also got some on the right hand, like P to print, O to open. Again, some Chrome specific ones would be like L to go to the location bar. And so the nice thing about the command key, and the reason why I consider it to be a superior choice to what you have on Linux and Windows, is that you can operate it with your left thumb. Now if we compare that with what you can do on Windows or Linux, like all of those same operations tend to be bound to the same key, but they use Control as the modifier. The problem with Control is it can be, even when it's remapped to caps lock, where it's more comfortable to reach, a number of combinations are harder to actuate when you've got your pinky anchored to the caps lock key. So pretty much all of these movements where the hand has to be anchored like that are uncomfortable. The pinky is the weakest finger on the hand. The thumb is the strongest thumb on the hand. So being able to just slide it over from where it's resting on the spacebar, just a tiny movement to actuate the modifier, makes it incredibly powerful. Especially if, like you notice my right hand is not here. My right hand's over on the mouse at the moment. So even though it's desirable usually to actuate modifiers with one hand and then the main key with the other hand, the reality is in a lot of our work we have our hand on the mouse, and so being able to actuate all of those that left group of keys with one hand just by moving the thumb is incredibly powerful. So you can imagine copying and pasting text from the browser just by making a small movement on the left hand is just way more ergonomic on Mac. And the other thing that I would add is because the terminal tends not to use the Alt key at all. It tends to focus on using the Control key, whereas the GUI apps tend to do exactly the opposite. That permits you to have these almost like two layers that tend not to conflict with one another at all. Whereas in Linux and on Windows, the Control key is heavily overloaded and just used pervasively, whether you're in the terminal or outside of it. Which means it effectively becomes real estate that's in higher demand, and there's more competition for scarce resources. It's harder to find bindings that don't collide. So those are the reasons why I think the Mac approach is objectively superior, and you're free to disagree, but I don't care, right? I'm a nice person, but I don't care. So that's the why of what we want to do here. We basically want to make all of those little control bindings on Linux work via the command key instead of the control key. Now, one suggestion that people often provide when you bring this up is like they say, well, just reassign command to the control key. And that'll work in a way, right? But the trouble with that is you're now, at least in my case, I'd be dedicating 6 keys to perform the function of control, because I have caps lock, that's control. I have the real left control key. I'd have the left command key also pretending to be control. I'd have the right command key pretending to be control, the real right control key, and the return key also pretending to be control. It's like 6 keys for one function is just not worth it. So if what I can do is map command plus a key to behave like control in the scenarios where it makes sense, that'll be a great win for me. Now I don't have to, when I do that, right, because I'm not unconditionally mapping the command key to control, I can use command plus another combination for different purposes. So for example, if I want to use the window manager to do stuff like I am now, for example, this is the i3 window manager, and I have command 1 and command 2 bound to move me between workspaces. So I can do that because I don't care to use the number keys for any other purpose, right? So effectively, it's about minimizing collisions. The stuff that I need to remap, I'll remap, and the stuff that I don't need to remap, I won't remap. So let's look, I guess there's one more thing that I want to note before I go into the details of like how I did this. First of all, there is a little complication, which is that if you look at this picture of an older Mac keyboard, you'll see here the second key, which is called Option on this one. It's also called Alt. So back in the old days, for some reason, the key that everybody else called Alt, Apple decided to call Command, and the key that nobody called Alt, Apple decided to call Alt and Option. Like, why does it have 2 names? I don't know. So for me, that's been incredibly annoying because I started using Macs over 2 decades ago. So for me, like that middle key there was always Alt. Yet when you talk to people from Linux, Alt means this one here, the big fat one. So that's annoying. So I've tried to start using kind of more agnostic terminology. Control is control. This one here I call Super, and this one here I call Alt. So I'm trying to basically get myself off of the Mac terminology. So while I think that the Mac layout is superior, the naming is definitely not superior. In fact, to help me do this, I made this page on my wiki about just to sort through the details of what the different names mean and what key codes they correspond to, and I made this little table. It's not even really complete, but everything's great when you're talking about control key because every platform calls it the same thing. But then, as soon as you get onto the next key over, like you're screwed because every platform calls it something different. And in some cases, they could call it really confusingly because Option is also called control. Option is also called Alt, depending on how old your keyboard is. And likewise, on the right side, the name given to the Alt key varies considerably. On Windows, it might be called Alt-GR instead of just plain Alt. And if you're going into the settings in Linux, it might be called ISO level 3 shift, which is, not super helpful. The other complication that I would like to note is that I use Colmac keyboard layout. And so, as I said earlier, caps lock is backspace, but also a lot of other keys are moved around. So it's just another layer of intricacy to deal with when setting all this stuff up. So to help me navigate these waters, I made this spreadsheet where, in this column I've got the key you would press on Mac, which is basically the key that I want to press everywhere. And then you've got the key that you would press on Linux to do the same thing. And then over here, after I've applied all my tweaks, I've recorded the key that you would press to get the Linux machine to do the right thing. So all these green rows are rows that I'm happy with because I've managed to get them to do what they should do in a Mac-like way. And at this point, there's nothing really stopping me from doing all the other rows. I just haven't done it yet. I feel like at this point I've demonstrated like as a, kind of like a technology demonstration that this is possible. And so I've just got to do the rest of the work. So let's look at tools. The first one is XModMap. This is probably the oldest and simplest mechanism for mapping, hardware key codes to like symbolic keys in Linux. So I initially tried this. I mean, as you can see here, here's an example, like key code 57 corresponds to the letter N. I initially tried using this and it works for some things, but I couldn't get it to work for all things. So I'm not even going to go into all of the details there because it turns out that, and what I didn't know at first is that the new and, why is this Spanish? I want it to be English. Was that one also Spanish? No, it was English. The new, more flexible way and more supported way to modify keyboard configuration is to use the set XKeySnail KBMap utility. So I was actually able to do quite a bit with that, which I'll show you now actually in the terminal. Let's get a split open and just do, actually no, let me show you my XKeyRC file. Okay, so I'm running Arch Linux here, which is a very minimal distribution, which, you know, when you do a base install includes almost nothing. It only includes the packages that you explicitly add, which is what I want. I want a minimal system. And so, for example, I don't have a so-called display manager. That means that when I boot the machine, I don't get a graphical prompt. I get just a virtual console, it's just a text console. And to start the graphical environment, I actually type start X. And this file is evaluated, which starts some stuff for me. And part of that is setting up the keyboard the way I want. So the first line just resets all the options, or rather unsets all the options, and then we turn some stuff back on. So we make sure we're in the US keyboard layout, the Colmac variant of it. And here's the first option here, which is shift both caps lock. And that does what I said before, where I tap it. I don't know if you can see it on the video there, but the caps lock light is now on, and I tap both shift keys again and it turns off. I'm also telling it to map Control-Alt backspace to kill the X display, the X window, sorry, the X server. Basically, if I ever screw up the GUI to the point where I want to get back to the virtual console, that will just kill the GUI and get me back to the virtual console. Another option which I did have here was one that sets the control key to behave like backspace when tapped, or like control when corded. And that worked great. And the reason why I haven't got it here anymore is because I moved on to another solution, which also handled the right side return key for me. And I wanted to use the same solution for both. I couldn't get the right side return key to work. There's probably some way to do it, but after several hours of trying, could not get it to work. So that's set XKBMap. Then what's next here? If you search for how to do this stuff with, make a Linux keyboard behave like map, you're going to pretty quickly run into this project called Kintosh. In the end, I didn't try this because it's built on top of another tool called XKeySnail, and this is probably highly opinionated. And so I thought, well, look, before I even consider trying this, let's look at the underlying tool and just test it. And so that's what I went to first, is XKeySnail. Now, this worked partially, but it didn't work well enough that I would stick with it. So basically, there's a few problems. One is that it's written in Python, so it has the usual kind of scary Python dependency graph. It runs inside X, so any changes you make here are not going to work on the virtual console. But annoyingly, it requires to run as root. So basically, if you want to start this thing, when you log in, you have to set it up to run as root without a password, which is obviously not an insurmountable obstacle, but it's just annoying. But it does, if we look at the examples here, it certainly does provide the kind of flexibility that you would want to do the kind of things that I want to do. So as you can see here, it's got this define multi-purpose mod map function that allows you to make a key like enter have two roles. So it can either be enter or right control. So that's exactly what I wanted, right? You can also set per application key maps. So here we can see overrides, remappings that only apply inside web browsers, or mappings that apply everywhere outside of Emacs and a terminal. So that's useful, right? But as I said, it had those drawbacks which dissuaded me from using it. Another one I looked at was this thing, SXHKD, which stands for Simple X Hotkey Daemon. And as you can see from the example here, that just enables you to bind arbitrary combinations to commands. So you can get a fair bit done with this. and I was using this along the way, and in the end I didn't need it, or all the things that I was doing with it I no longer needed it, so I stopped using it. If you're using a window manager like i3, you can set up bindings like this anyway. I think the main reason you would use this would be to have some kind of window manager independence, but at this stage I don't really want that. I just want to invest in i3 and get it working as well as I can before I worry about being able to switch window managers easily. Because I'd rather not switch, to be honest. I'd rather just have something that works. So finally we come to a key part of the puzzle that enabled me to get this working, and that is interception tools. This is the closest thing to carabiner elements that you're going to find on Linux, as far as I know. It uses, most importantly, the libevdev layer, which is, it's basically a userland way to access input devices. So you don't have to plug anything into the kernel, but it does sit right above the kernel. And so it's very low in the stack, it's below X. So it enables you to do fairly pervasive stuff in a fairly not dangerous way. I mean, you can still screw your keyboard up, so you have to be careful when you're changing things. But the example they give, just to illustrate how this thing is used, here it is. It consists of two programs. This first one, Intercept, it basically grabs the keyboard device using this library and makes it so that the other applications don't see it anymore. And then it emits a stream of input events that you can then pipe into this other program called uInput, which takes the stream of input events and creates a clone of the keyboard device, creates a virtual keyboard. And so in this pipeline, you can insert transformations that change the event stream. And so the example they give is that they have this X to Y program, which you just stick in the pipe there. And as you can see here, all it does is, anytime it sees the X key, it turns it into a Y key. You can arbitrarily string these pipe-based transformations together to do anything you want. And so they have a couple of official plugins that you can look at for examples. Where is this? Plugins. So the one that I found particularly helpful is this one called Dual Function Keys, which handles the caps lock and return situation that I wanted to handle. You basically just give it a YAML file where you say, given a string, I want it to do this when tapped and this when held. It works great on both sides of the keyboard. Because it's running above the kernel but below X, it works in the virtual console, which is great. And so that's what I'm using to do the chording and tapping behavior. Then I made one of my own plugins, which I'll just show you now. That'd be Mac to Linux. So this is just a little C program, and you can see the core of it here is this array of structs. So basically, it's going to read events, and based on the remappings defined in this list of structs, it's going to transform the events appropriately. And so, if we see the Colmac A key held or tapped with the Alt key, then we should turn that into the Colmac A key, but with the Control key held. And so a lot of these are just simple remappings of basically transforming the Command key into the Control key. But we also have some down here, like left brace, for example. When I hit Alt left brace, I turn that into Alt left, which basically does a back navigation in Chrome. So as the to-do here notes, ideally I would only do that in Chrome. But I'm doing it everywhere because at the layer that this code is running, it doesn't know what the frontmost application is. So this is okay because I've got that spreadsheet, which I showed earlier. And this is basically here I have a way of tracking like where I'm using the different keyboard shortcuts. And yeah, ideally I'd be able to do this on a per application basis, but so far just doing it globally has been okay. And ultimately when I'm programming, I'm spending most of my time in the terminal or in the browser, so I don't actually care. About doing these globally. At least I can use my muscle memory. It's not my ideal solution, but I can use my muscle memory, so that's good. So we've got all these mappings, and the details of this code are quite inconsequential. As you can see, it's 571 lines, but it doesn't matter. The struct is the important thing, because it defines what we want the darn thing to do. So one thing to notice about this, I'll give you a demo actually in the browser. I've got screen keys showing what keys I'm pressing. So you'll notice that, for example, if I want to go, if I want to move between these tabs, I'm going to hold Command, Shift, and then I'm going to use one of the square brace keys to move forward or back. And you'll notice screen keys is showing that that's being transformed into Control Tab or Control Shift Tab. Now, Control Shift Tab is a horrible key combination to press, because I mean, look at these keys, like Tab, Control, and Shift, all far over to the left, involving the pinky, just super awkward. And even if you remap Caps Lock to Control, it's still 3 keys, one above the other. It's basically the worst possible combination you could type. So, at best it's going to slow you down because it's such a long movement, and at worst it's going to probably provoke an injury in the long term because of the contortion it requires you to put your hand in. As opposed to this, which, as I said, is a small movement of the pinky, a tiny movement of the thumb, and then another movement on the other side. So you're using both hands to do this. Each hand does a little bit less work, so it's faster and it's less stressful. What's another one? Another one would be Command L to jump to the location bar. You see there that the operating system interpreted that as Control L. And let's go to a page with some text on it and do Command F to find. Now those two, I think, if I recall correctly, are examples of bindings that you can't override with a tool like XKeySnail because it sits too high up in the stack. Somehow, I'm not actually sure how, Chromium grabs those events before XKeySnail sees them, and it uses them to focus this menu up here, the Chrome menu. And so you've got to get below, you've got to get under Chrome to make this work. So that's why the interception tools work well there. And so finally, I guess there are maybe 2 more interesting things to look at. One is, how do I handle that whole Control-I dual role thing where I want Control-I and Tab to work in Vim. And the solution is in the terminal emulator. I'm using Kitty, which is super fast and super configurable. Let's go to my Kitty configuration. Kitty conf, there we go. So down here, you'll see when I hit Control-I, it's actually going to send a different key code. That's the key code there for F6. So this works. There's a fold there that I'm on. If I hit Tab, I can unfold. And you see, hitting Tab repeatedly toggles the fold. But I can also jump around the file. So just say I go up and down, and then I hit Control-O and Control-I. You'll see that that worked. So even though in the terminal, those keys look the same, to the higher layer that Kitty itself is running at, it's obviously outside the terminal, it's in a position to intercept those events and rewrite them for me. So I didn't need the per application targeting that Carabiner Elements provides. I was just able to do it within this application. And another example would be what I'm doing in i3. So I think I've got that open somewhere. Yeah, i3. So there's a bunch of docs in here about how to bind key bindings. So let's have a look actually at the i3 config. And I'm on the right line already. Okay, so I've got a bunch of stuff in here with bind sim. As you can see, I'm using Alt for a lot of things where it doesn't collide. In places where it does collide, I'm using other keys. So for example, down here I've got some super bindings to move focus, super shift, and so on and so forth. But this is the interesting one that I wanted to show. When I hit Command V, which is paste, I've got it running a script. So let's go to that script. It's somewhere here. Why are you not finding that file? Okay, let's just jump to it. So this is the file that runs every time I hit Command V. It uses xDoTool, which is basically an automation utility for X, where you can get information about Windows and create events that interact with Windows. So it gets the currently focused window, and if that is Kitty, it sends Control-Shift-V to Kitty, which pastes, and if it's not Kitty, it just sends a normal Control-V, which is a paste everywhere else. So the reason why Kitty wants Control-Shift-V for paste instead of Control-V is that Control-V is often used in the terminal for other things, like most obviously in Vim, it's used to go into visual block mode, right? But other things as well, like inserting literal sequences in insert mode and so on and so forth. So let's do a demo of that working. I'm going to copy some text. I'm using Command C, which, as you can see from screen keys, the browser and everything on it saw as Control C. So that's in my clipboard now. Then I hit Command Shift Tab to go to the previous workspace, which was translated to Alt Shift Tab. And now it's in my clipboard, so I can paste it. So I'm going to do Command V, and you see it pasted in. So even though I did, let me type that again. Control V, yeah. So I typed Control V. Well, the OS saw it as Control V, but Kitty transformed it into Control Shift V. Or rather, Kitty saw it as shifted because i3 ran the script. Sorry, I'm getting a little bit confused here. All right, so that's paste in the terminal. And now if we go back here, let's just copy some more text and paste it up here. That just did Control V, right? So copy and paste is working. And one of the reasons it's working nicely is because I'm using Clipper. Now Clipper's a background process that runs anywhere you want. So I run it on my Mac machine, I run it here on this Linux machine, but if I was SSHing into a remote host, I could set up a reverse SSH tunnel and talk to the Clipper instance on my machine. What it does is basically put stuff in the system clipboard for you. So that means that I can do stuff like, if I hit YY to yank a line in Vim, that's now in the system clipboard because it's easy to set up Vim to send stuff via Clipper into the clipboard. So if I hit Command V now, oops, that didn't work. That didn't wind up in the system clipboard. Let's go here and put it up there. No, that didn't yank it. Clipper might not be running actually, so let's look into that. It is not running, but let's start it. Okay, let's try that again. We yank this line, and now I go somewhere else, and I can paste the line. Okay. Similarly in tmux, let me go into tmux copy mode, and I'm going to copy that line, and then I'm going to go up to my Vim buffer and paste it. Right. So another thing I can do is just get some command output. So if I less and pipe stuff into clip, now it's in the clipboard, and I can stick it in there. Right. So this basically makes working with a clipboard a little bit more pleasant. And more pervasive. You don't have to think so much about like where am I on the right machine or not, what OS am I on. It just makes everything behave kind of in a Mac-like way. So that's, I think, all I've got to show at this stage. As I said, it's a bit, there's a lot to say about it, so I kind of glossed over a lot of the details. And I expect to continue evolving this setup because I've still got plenty of keys to deal with in my little mapping chart here. But I will probably break this down into more detail in smaller screencasts in the future. But in the meantime, I hope that was useful for you. And I'm now going to try to get this video off the 3 different devices where I've been recording it and put it all together in one place. And I'll probably have like a 45-minute screencast as a result. Oops. Oh well. Catch you later. See you next time.